Large language models are absolutely incredible, but they have a huge problem. They're basically trapped in a box. They can think, but they can't actually do anything. So the big question is, how do we bust them out of that box? How do we let them safely use tools, grab data, and actually get stuff done in the real world? Well, that's exactly what we're going to break down.
Now, you'd think this would be easy, right? I mean, just let the AI call an API and you're done. But oh man, if only. The reality is, it's a super complex problem. And the ways we've been trying to solve it so far, let's just say they're messy, not very smart, and honestly, kind of scary. So what's the deal? Why is this so tough?
All right, so the heart of the problem really boils down to two words: tool chaos. Seriously, for the longest time, the world of AI tool integration has been like the Wild West. No sheriff, no rules, just everyone doing their own thing, and it's been a total mess. Okay, so picture this, right? Every single AI framework, think LangChain, think OpenAI, they all had their own unique proprietary way of saying, hey, use this tool. It created this absolute spaghetti junction of code. Tools were basically glued to specific models, so you couldn't reuse anything. And even worse, this free-for-all approach was a huge security nightmare. There was no standard way to put up guardrails, to say, hey, AI, you can't touch that. It just left the door wide open for things to go wrong.
But what if we could bring some law and order to this Wild West? What if there was a universal translator for AI tools? Well, that's exactly where this solution comes into play. It's a universal bridge, and it's called MCP. So MCP stands for Model Context Protocol, and really it's just an open protocol that was built specifically to clean up this mess. The whole idea is to create one single standard way for any large language model to talk to the outside world. No more chaos.
And honestly, thinking of it as a bridge is the perfect way to get it. MCP isn't the AI, right? And it's not the tool either. It is that super secure, super reliable bridge that sits in the middle, making sure the two can talk to each other safely and, well, without blowing anything up.
So yeah, the goal here is much bigger than just making it work. It's about finally taming that Wild West. It's about building a system that is safe, structured, and can actually scale up to handle the big, heavy-duty tasks you'd see in a real business, all without, crumbling under the pressure.
Okay, so we've got the what and the why. Now for the fun part, the how. How does this bridge actually function? Well, it all revolves around one central piece of the puzzle, something called the MCP server.
Yeah, the best way to think about the MCP server is as a security guard or a gatekeeper. It's a service that runs in the background, standing right between the AI model and the rest of the world. And its job is to manage three core things the model might need.
First up, you've got tools. These are basically the verbs, the actions the AI is allowed to perform. So let's say you're building an AI travel agent. A tool would be the ability to query a flight database or book a hotel room. They are the specific, executable things you want to let your AI do.
Now, this next part is maybe the most important piece for security, so listen up. The LLM, it never, ever runs any code itself. It can't. All it does is request an action. It's kind of like it's filling out a permission slip. It says, hey, server, can you please run this tool for me with these details? And the server is the one that actually does the work. That separation is absolutely critical. It's what makes the whole thing safe.
Okay, next up we have resources. If tools are the verbs, then resources are the nouns. This is all the read-only information the model can look at to get context. So, for our travel AI, a resource might be a PDF of the user's travel history or a link to a knowledge base about airline policies. The key thing here is read-only. The AI can look, but it can't touch. It can't change a thing.
And the third piece of the puzzle is prompts. Think of these as reusable instruction manuals for the AI. So instead of typing the same instructions over and over, you create a template. For our travel agent, a prompt might be something like, you are a friendly and efficient travel assistant. Your goal is to find the user the cheapest flight that meets their needs. By managing these in one central place, you make sure the AI always behaves consistently. And if you want to change its personality, you just edit the prompt. No coding required.
So you've got tools, resources, and prompts, all safely managed by this gatekeeper server. Now let's put it all together and really see the difference this makes. Let's look at a before and after.
Okay, check out how clean this flow is. First, you, the user, ask the AI for something. The LLM figures out it needs to do something, so it turns to the MCP server and asks, hey, what tools do I have? The server shows it the menu of approved actions. The LLM then picks the right tool, fills out the necessary info, and hands the request back to the server. The server does the actual work securely and then hands the result back to the LLM. Finally, the LLM uses that result to give you your final answer. See? It's like a perfectly choreographed, super secure conversation.
I mean, when you put them side by side, the difference is it's night and day. The old way was total chaos, right? No standards, you couldn't reuse anything, and the security was, frankly, a joke. But with an MCP server, everything changes. You get standardization, you get high reusability, and the big one, you get rock-solid security and governance. This is what makes it ready for the big leaks, for real, enterprise-level stuff.
So what's the big payoff here? What does all this actually mean for people who are trying to build serious, useful AI systems in the real world? Oh, the payoff is massive. First, you totally separate the model's brain from the tool's hands. This creates this beautiful, clean architecture where the model doesn't care what tools it's using, and the tools don't care what model is calling them. You know what that means? You can upgrade or swap out your LLM anytime you want without having to rewrite everything. It makes testing a breeze, and it lays the groundwork for truly safe, governable AI systems that are ready for production.
And this isn't some far-off theory, by the way. This is happening right now. It's the engine behind those super smart AI coding assistants. It's what allows data analysis agents to dig into databases for you. It's powering the secure chatbots that big companies use, and it's even automating really complex stuff in DevOps. It really is the essential backbone for any AI agent that needs to do things.
So look, if you take away just one single thing from all this, make it this sentence. LLMs think, MCP servers act. It's that simple. That phrase just perfectly nails the entire philosophy here. We let the big, powerful language models do what they're amazing at, thinking, reasoning, planning. And then we let the MCP server do what it was built for, to safely and reliably take those thoughts and turn them into action in the real world. It's this clean separation that's paving the way for a much smarter and much safer AI-powered future.